PriorityVax is an online tool to support a process of priority setting and decision making about vaccines that is tractable, transparent, and evidence informed. With PriorityVax, you can capture the deliberative process about opinions, drivers, and rationale for a decision, including how evidence is used as you move from data to recommendation. PriorityVax can be used by any stakeholder with an interest in vaccine priority setting, but it is most useful to those who want to follow an evidence to recommendation framework. In this video, we will look at how evidence can be updated and how what-if scenarios can be run through PriorityVax. This use case comes from an application to Gavi to help introduce pneumococcal vaccine, PCV, into Papua New Guinea. The application was made in 2011 and asked for a first preference of PCV 13 or a second preference of PCV 10. A choice facing many countries, especially those that are graduating Gavi, may be selecting between products. Gavi sources vaccines, so this is less of an immediate issue for places like Papua New Guinea at the time of this application. But for many middle-income countries, and in particular those that are just graduating from Gavi or are not eligible for co-funding, this can be a real challenge. PCV is a nice example because the two main presentations, a 10 and 13 valent vaccine, are broadly similar, even in the strains they cover. However, there are some notable differences that we've drawn out using the evidence from the Papua New Guinea application to illustrate some of the hypothetical discussions about which one to prioritise. We can start straight away with the selection criteria. In this case, we've made up some relevant criteria. In their application, a nice rationale was made to prioritise PCV 13, principally based on the coverage of serotypes. We've picked out 4 criteria. The serotypes that are covered, the storage space requirement, because this has implications for cold storage capacity, as well as local and national storage and transportation costs. The cost per dose, which becomes relevant after graduating from Gavi. And with PCV 10, there is a tangential benefit of reduction in the risk of otitis media. I first want to show you the type of evidence might be used to illustrate how different attributes might be included. These 4 attributes are defined quite differently. The serotypes covered is the percentage of serotypes that are known or suspected to circulate that are covered by the vaccine. It ranges from 0, bad, to 100, good. The storage requirement is the volume in cubic centimetres for each vaccine. In this case, lower numbers are preferable. The cost per dose is the price in US dollars. And all of these contrast with a 5-point Likert scale that was used in the Uganda use case video, because they're on a natural scale, i.e. the observed units, and they also differ from another sort of attribute, which is a binary, for example a yes-no question, as is the criterion for the protection against otitis media. We can then enter data, and in this case from literature, using simple sliders and switches. Citations from all the evidence that was used can also be entered, and these are carried through to the report generated by PriorityVax to keep a clear audit trail from the evidence to the recommendation. Using the data from the Gavi application and our selected criteria, PCV 10 would have been prioritised. In this example, we used serotype coverage from the application, and at that time it was the best available data. But it wasn't actually from Papua New Guinea. It was from a regional estimate of a global study. At the time of the application, there was a randomised control trial in Papua New Guinea that published more relevant figures a few years later. And because we can reconfigure our analysis, we can update our evidence to reflect the latest information. Overall, the number of serotypes found circulating in Papua New Guinea was much higher than the global study had reported. And consequently, the number of serotypes protected against is lower for both PCV 13 and PCV 10. But PCV 13 would cover about 15% more, and so the relative value of this vaccine increased because serotype coverage accounts for about 50% of the weight. However, we can further update our priority setting because from 2011 to 16 there was a second RCT in Papua New Guinea. Here the serotype coverage is almost the same for the 2 presentations. And given our other attributes, principally storage requirement, PCV 10 is still preferred. The storage needs is interesting because it has an implication for future expansion of the national immunisation programme. Shortly before this application, Papua New Guinea had expanded its capacity with assistance from Gavi, and they had more than enough capacity for either of these 2 vaccines, but the requirements of the presentations is markedly different. Using PCV 13 would mean there is less space in the system for future change, and an EPI manager, for example, might have a rather different sense of priorities from a clinician, in this case, for example, putting storage over serotype coverage.
Equally, if we're exploring future scenarios, we might consider full costs rather than co-funding. And it's worth noting that we use the built-in weights, which is based on the order of criteria. It biases the weight of each criteria to the first criterion, and then the second and third, so on. But you'll see that the more criteria you have, the less weight each is given, so they very quickly become incidental. While we update the configuration, we can increase the cost per dose to reflect 2018 prices, reported by countries without Gavi support and who secured vaccines for themselves. The prices are quite similar for the two PCV presentations, but PCV 13 is a few dollars more per dose. The consequences are again that PCV 10 is favoured. In this case, it costs less per dose, and that was our most important criterion. Second, it takes up less volume for storage, and that was our second attribute. We can see from this that PriorityVax can quickly illustrate the consequences of exploring uncertainty in the data. In this example, using updated information, but it would be equally true if looking at a range of published estimates, or that the process was being reviewed in light of new information. This is in addition to the ability to quickly explore what-if scenarios, to look at future information, like the later RCTs, or exploring new circumstances, such as the cost if a country graduates from Gavi.